was a problem with, I think, the limit as x approaches 0. I think it was, was it from the right? Of course.
Yes.
Yes. Natural log x minus 1 over x. And I want to talk about this. It was a homework from last time. But the reason I want to talk about it is because the question is very legitimate. How do I show my work? Okay, I know the answer is blah, blah, blah. But how do I show my work? So what I showed in my solutions, and maybe that is not very clear, is I showed that this, as x approaches 0 from the left, a natural log, so here's the graph of natural log, as x approaches, was it 0 from the right? Am I correct?
Yeah, it was 0 from the right.
So this is all correct, yes?
Yes.
Okay, perfect. So as x approaches 0 from the right, as you know, this is natural log, and this will approach negative infinity. There is no discussion there. Okay, now here, 1 over x. So the graph of 1 over x as x approaches 0 is this. And of course, this is the entire graph of 1 over x. And as x approaches 0, this goes to infinity. So this piece goes to infinity. And negative infinity minus infinity is negative infinity. Did I make an error in my solutions? If I did, I apologize. Oh, it was different. See, it was not that. Yeah, this is not the correct function. It was 1 over x minus natural log x. Okay, so let's do it again. Okay, so it's limit as x approaches 0 from the right from 1 over x minus natural log x. This is correct. Everything is correct here, but the problem we had was different. Okay, so now I know from my graph that this approaches infinity right here. And I know from my graph that this approaches negative infinity. But infinity minus negative infinity, it's clearly infinity. There is no need to graph this function. Just analyze each piece. These are basic functions. What do I mean by basic functions? Basic functions, I mean the simplest possible, like x, x squared, x cubed. From each category, this is the simplest possible function. Linear, quadratic, cubic, natural log x, e to the x, right? 1 over x. These are functions with no transformations. The simplest possible: linear, quadratic, cubic, natural log, exponential, rational, and we can go on forever. Trig functions, inverse trig functions, hyperbolic functions, on and on and on. So the basic functions, the graphs of the or arctangent, as I mentioned, and so on and so forth, these have to be known. And you can graph them and say, oh, I can see very clearly that this approaches negative infinity. Here I can see very clearly it approaches the vertical asymptote from the right, it's positive infinity. If this was not, were not infinity plus infinity or negative infinity minus infinity, which the result is very clear, if I do get this, this does not have an answer. I have to investigate further. This is called indeterminate. For this one, you don't have an answer. We have to dig deep, step by step. There is a big analysis, and then we come up with whatever. Okay? But the situation was simpler because it was infinity plus infinity. Is this okay with everyone?
Yes.
Perfect. Now, which problem we want to look at next? What did we have next on our agenda before we start? Yes, I forgot. Katie, what did you want? Yes, I remember now. That squeeze theorem, right? That was my next one, correct? If you're talking to me, you're muted. Are you talking to me? Okay, I'm not sure. Did we lose Katie?
Can you hear me?
Yes, now I can.
Yeah, I think that was the problem we were working on.
Very good. So let's go to, I'm going to share my screen. Where are you guys? I lost you. I found you. Okay, so we're looking at 2.3. I removed one problem from the homework for today. Again, as I said, if you did it correctly, you get extra credit. Okay, and I think it was 40 something, something, because I want to explain this. Okay, it's a little bit, it looks sophisticated. It's not, but let's do it together. Okay, let me copy it and I'll stop sharing. So this is limit as x approaches 0 from the right, the square root of x e to sine pi over x. Okay. So obviously, this approaches 0, right? This is, I don't know. So whenever I get a situation like this, I shouldn't say always, because we are going to get something similar, but later that looks the same, but it's not really the same. So I have to start by analyzing this function. I don't know what to answer here, because it's 0 times e to something that does not exist. So I cannot conclude. You can say 0 times whatever, it's always 0. Not necessarily. Not necessarily. So a deeper analysis is required here. So let's do just that. Okay. So first I will start with sine as we did last time. I like this function because it's bounded. Can anyone remind us between what and what?
-1 and 1.
Very good. As we know, bounded like, okay. Now, see, I reached this stage. Don't even look at, where's my, I lost my other eraser. Okay. Don't even look at this side. So we are really talking about e to something. When I talk about e to something, I immediately imagine its graph. And you can say, why do we have to do that all the time? Well, because knowing that the function is increasing, and also knowing that sine is an increasing function, then e to -1, e to sine pi over x, and e to the first power will also be increasing. If I have cosine in here, cosine is a decreasing function. So it's a different analysis. Who knows, right? But sine is increasing, e to the x is increasing, which means that if I apply this power to e, this power to e, and this power to e, these numbers have to be increasing. Therefore, all I need to do next is multiply, like we did last time, all three sides by the square root of x. So this is the square root of x divided by e, less than or equal to the square root of x, e to sine pi over x, less than or equal to e times the square root of x. Finally, I build the function that I'm interested in the middle. Let's call it h of x. I have the lower bound. I have the upper bound. So the first hypothesis of the squeeze theorem is fulfilled. And now I'm working on the second one. As we know, I have to find the limit as x approaches 0 from the right from this piece, and the limit as x approaches 0 from the right from this piece. And if they happen to both exist and be the same, then I know by the squeeze theorem, blah, blah, blah. So Can anyone give us the answer? And I'll sip water in the meantime. Anyone?
Wouldn't both of them just be 0?
Absolutely. And then why do we conclude about limit from the square root of x e to sine pi over x as x approaches 0 will equal to?
We'll conclude it's equals to 0.
Absolutely. Because both conditions are fulfilled. I sandwiched the function between two other functions near 0. I don't care if this happens all over. It does. But I don't care if it does. I only care what happens around 0. It's squeezed. It is squeezed between two functions. These two go to 0, then this one must go to 0. So yes, there was a trick in there. We had to discuss it, so that's why I removed it. Thank you for talking about this one. Okay, do I owe you anything else? Is there anything else that I need to go back to? Any problem?
Yes.
Yes?
Can we try
Yes?
4?
I didn't hear what you said. You said 24?
Yes.
Okay. This one? We had an example similar. Allow me to copy it and then I'll switch. So this is 24. So limit as x approaches 2 minus x, the square root of x plus 2 minus 2. Okay. So in this situation, of course I have to plug it in. Luckily the top is 0 and the denominator is 0. So my only chance is to rationalize. So I'm going to write it again. Please do not drop the limit operator. 2 minus x, the square root of x plus 2 minus 2. And can anyone help us what we rationalize by?
Would it be conjugate?
Yes. Very good. Thank you both. So can anyone give us the conjugate?
The square root of x plus 2 plus 2.
They have to be the same because this must equal 1. Otherwise, I change this function, and I'm not allowed to. Okay. Great job so far. Okay. Next, I will multiply. Okay. So I get limit. Don't drop the limit operator, please. I know it's tempting. So I can rearrange that normally as x minus 2 because it's twisted. Then I have the square root of x plus 2 plus 2. Can anyone give us the denominator? Remember, we are using a minus b times a plus b.
X plus 2 minus 4.
Very good, awesome. So this becomes, remember, x minus 2. So limit as x approaches 2, negative x minus 2, the square root of x plus 2 over x minus 2. The problem is gone. There is no more 0 over 0. And now I can drop the limit operator as long as I write a number here. No x or something else. So what do I write?
Negative 4.
Excellent.
4.
Negative 4 indeed, because there is a negative here. So again, I don't mind begging my students. I am begging you to redo the problems we do in class first. It will help you tremendously. You will see the difference. Okay, anything else or can we move on? Is there anything else I owe you? other than morally.
Can you do 28 really quick?
Yes, of course. Yes. Let's take a look. Where is 28? 28. Yes. So in 28 we have limit as t approaches 0, 1 over t plus, oh no, I'm sorry, t squared plus t, it's minus. Okay. Again, in this situation, I can't really plug in at this stage. I will, but I can't right now. I hope we never run out of whiteouts. So, as I don't know what I would do. Okay, so I have to find the least common denominator, and I always factor. So then limit as t approaches 0. The least common denominator is t plus 1. So this is the same. So this needs a t plus 1. So at the top, a t plus 1. So t plus 1 minus 1, that would be t. T plus 1 minus 1. Now, of course, this has to go away, and the answer is 1 over 1. Good. Other questions? Is there anything else I owe you? If not, I'd like to go back and close up to that 4 and move on. It's a lot of work. I know we only cover four chapters, but it's a lot of work. Oh, there was that one with the absolute value. Do you still need me to show that, or can we move on?
Yes, I would like to see that. Yes, please.
Very good. Can anyone remind me which number it was? Because I didn't. Oh, I got it. I got it.
46.
46 it is. Okay. So we have limit as x approaches negative 2, 2 minus the absolute value of x over 2 plus x. This one has a little twist as well. Okay, so I can't analyze this. No, at this point I can't do anything. I have to simplify the function first. I will start with this piece because this has two options. This doesn't have two options. This doesn't have two options. This doesn't have two options. Only this one has two options. So that's my starting point. So I start with the absolute value of x. And I know from last time that this is x greater or equal to 0, negative x less than 0. But what I'm interested in is 2 minus the absolute value of x over 2 plus x. Because this piece has two options, this piece will have two options. One option will be with 2 minus x over 2 plus x, when this is x. And the other option, when this is negative x, this will be 2 plus x over 2 plus x. But be careful now. I have to write x greater than or equal to 0. I have to write x less than 0. But this has a problem. What is the problem?
It's undefined at x equals -2.
Brilliant. So now careful. Where is negative 2? Is it here? Or is it here?
The bottom one?
Very good. I have to put it in. X not equal negative 2. This I cannot, so I continue. This I cannot simplify. There is nothing I can do there. 2 minus x over 2 plus x for x greater or equal to 0. Can I simplify this?
Yes, it would be this one.
Very good. For x less than 0 and x not equal negative 2. Okay, now I can go to the limit as x approaches negative 2 from either side of 2 minus the absolute value of x over 2 plus x. Again, where is negative 2? I know it's silly, but I want to make a point. Is it here? If you say it's here, then I will have to use this. If you say it's here, then I will have to use this simplified form. Where is negative 2? Top or bottom?
Bottom.
Good. So then limit as x approaches negative 2, this piece will be replaced by
One.
exactly, because that's a simplified form when x approaches negative 2 from either side. It's 1. So then what is the final answer? Nobody cares where x is going when it comes to a constant.
1.
Exactly.